All right, this is part 2 of a multi-part series I'm doing on setting up subwoofers and subwoofer arrays. In the first part, I covered measuring or predicting subwoofer arrays in a wide frequency response, well above where you're going to cross them over in order to get a better idea how they'll actually perform, and looked at a single sub, 1 sub per side, 4 subs per side, and a line of subs across the front of the stage and the assets and issues associated with them. In this video, I'm going to cover some more complex arrays, and let's get to it. Let's see what happens if we splay these, if we just physically start tilting these, but we keep them in somewhat of a line. I mean, if this is an emulation of an arc, like a Fresnel lens type thing, if we had actually arced them, they'd have a lot more depth, and we might not be able to get that behind the barricade. It would push the audience out farther from the artist, and since our main purpose is to connect the artist with the audience, creating a sound setup that disconnects the artist from the audience is generally undesirable. So this is kind of an emulation of the two. There is no delay on this setup, but we'll look at it with purely mechanical angling. And there's 20 hertz, and we can see that this has actually gotten wider. And remember that other one was just really got in to be a laser beam, and here we're starting to see that it's a little wider. And we've got bigger side flares. It's not great, but it is not nearly as dramatic as it was. Okay, so now let's add some delay time to these and form an actual arc with a splayed arc. Splayed and delayed arc. And there's what it would look like. Now look at this. Now we've actually got this stuff that starts to look like a single sub did at 20 hertz. It's nice and omni looking, or at least round. And that looks quite good as well. We've still got a lot of energy showing up on stage and a lot of subs close to the audience, close to the artist. That's quite a good coverage. I'm really liking the way that looks. But look what happens at 63. We start to see this fall apart. Now, if we looked at an average of those last 3, that would look really good in most software. But if we start to look at these higher frequencies, see this from 100, see how it flips and a lot of energy goes around behind, and see how it's changing drastically. Each frequency gives you a completely different flower here. So it gets messy. It seems to, it's jumpy. It's very drastic. It doesn't have that smooth, changing alteration that we saw with the like 1 sub per side, where it slowly went, as it went up and down in frequency. Here, what I did was I did some plots with a M3D cardioid sub, an older sub that had rejection around back. And these should reduce the amount of energy on stage. So taking that same setup and trying to gain the advantages that we saw between 20 and 80 hertz and minimize the impact upon the artist. And that looks great at 40. That looks great at 50. 63, this is another good looking setup. 80, it starts to fall apart, but it still looks good. And now it flips and we're getting some various hot spots and nodes. So for lower frequencies, I would say this is pretty well behaved, but once we get up to the higher frequencies, it's not as behaved as we'd like it to be. Now here is an actual arc. So let's take a look at that, and there's no delay on it. And it's looking pretty good. Got a little mushroom there. Lot of volume on stage. When you're equidistant from a single point, you get maximum volume. So the loudest output for this setup is right there. And the artist would be right back here, and this pushes the audience away. So this actually looks quite good for the audience area and quite undesirable for the artist area. So if you don't have an artist that, if you have a pre-recorded music or something, this can be in a very effective setup. But if you have somebody on stage playing, this amount of volume there would be highly undesirable. Still looks pretty good. That's looking good. It's clean. It's holding up. Look at this. We're all the way up at 125, 160, 200. That really held together. This natural arc is just gorgeous for the audience area. That's a good looking array that holds up through higher frequencies, with the big issues being pushing the audience away from the artist and the excessive volume on stage. So let's go ahead and do that with a cardioid box. And that looks wonderful. Wonderful as well. We've dealt with the volume on stage. The only real issue here is pushing the audience away from the artist. And because of the cardioid design, we lost a lot of volume there. So this is inherent to the box. This won't be as drastic or more drastic with differing cabinet designs as the M3D. So this is going to be a little more unwieldy. But up through 100 hertz, this looks quite good. Not necessarily usable, I would say, for most applications, but there may be applications that it is good. This natural real arc is a beneficial setup. Now let's do this arc emulation. So let's take and recreate that arc by taking a series of subs and delaying them to form a virtual arc. And these also have a slight spacing between them. And the spacing between them will create its own set of issues. So there it is in front of the stage. And that looks just fine there. Now we're starting to see various nulls happening in the audience. We're seeing this start to break up at 50 hertz. And by 63 hertz, it is got hot and low spots. So now this is starting to, these are the visuals that I associate with a lack of high frequency response or an unstable higher frequency response to a subarray. And this is where a subarray maybe instead of going doop, 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 goes blue, 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 or bleh, bleh. You know, it's got some push to it. It kind of warbles, it stumbles. It doesn't have that distinct, clear hit to it that would be imperative for like an EDM show. And if you're doing something that doesn't require low end and you just need a little bit of rumble behind it, is just fine and not an issue. So it really is application dependent. And we can see that it's really falling apart here. 125 all over the place. We are getting low end everywhere, but it's a mess. It's just a messy bleh. not necessarily what I'd be looking for a nice, clean, clear low end. It may seem desirable because it's even, and compared to like that one sub per side, you've got even coverage, but this kind of sounds mediocre or poor everywhere rather than really good and pretty good, and then having these holes between where it's doesn't necessarily sound bad, just isn't enough low end. So now let's look at actual arc versus a delayed arc. And we'll put them side by side in the same venue. So if you did one side. Now in this delayed arc, I did the opposite. I didn't splay them. I formed the arc and pointed them all forward. So it's physically just moving them back in time and electronically moving them back in time. But comparing apples to apples, I haven't changed the angle of the sub. And they're the same array. And we can see the difference between electronically forming the arc and mechanically or naturally forming the arc. And I should call back. I'm going to go back and call out these frequencies. 20, 40, 50, 63, 80, 100, 125, 160, 200, 250. And we can see that the natural arc was much more stable as we raised frequency than the delayed arc. This delayed arc introduces almost like a low pass filter or a destabilization of high frequencies. So that's something to be aware of when you're forcing delays versus using natural physical distances to achieve a coverage or an outcome. Okay, 4 dual 18 subs per side in a spaced arc. So now I've put an arc on each side to try and increase the coverage. One of the big issues as you increase the amount of subs is that the coverage collapses. It becomes very narrow. And there we can see it at 20 hertz. And 40 hertz. This design actually is pointed out a little too far. I went too drastic. These are pointed out at 90. I think that pointing these, maybe having the second box pointed straight and rotating these in about 20 or 30 degrees would be more desirable. But we're seeing pretty good energy out here. I mean, we've really done well. And in fact, as an overall picture for approximately 120, 150 degree coverage, we've got excellent coverage for this third of the people, excellent coverage for this third, excellent coverage for this sixth or 12th. And these areas here are lacking. So overall, per quantity of people covered, we've actually made quite an improvement if we're covering that width. And our issues have been moved to the center, but we've done a great job off to the side. Look at that. That's really quite nice at 80. And we start to fall apart at 100 hertz. 125. 160, and we're the spacing between them is now relevant to the frequency of coverage, so of frequency being reproduced, which is why we're seeing all of that high frequency issues. The arrays are spaced arrays without the boxes, without the speakers very close together, is going to have challenges with higher frequencies. This is why for a line array design, all the speakers are so close together vertically. Any spacing between them causes issues at higher frequencies. And the closer the drivers are together, they more act like a unified source. All right, 2x2 end fires. Now, end fires, in another video, I'll show you how to build these up and design them in Sound Vision. But what we've got is the sound is coming out of the rear sub first, and the front subs are waiting for the sound and then reproducing the sound. and so that they're summing in front. And since it comes out of the rear sub first and then comes out of here, from this perspective back on stage, it hears the sound, you hear the sound from the rear sub, and a little while later you hear the sound from the front sub, and there's a time differential between them, and we get some cancellation here, and we should see that. And I'll go in more depth about setting up these end-fire arrays and timings on those. There's an example. It's Ronnie at the Sahara tent many years ago at Coachella. And we've got an end-fire array as the basis for the stack for the subs on the side, because we wanted low end to be maximized inside the tent, and behind we had another tent over here, the Mojave tent, which we did not want the low end going to. So this was a way of reducing the level headed in that direction, similar to if the band was back here or the artist was over there. Well, we can look at 20 hertz and the depth of these nulls and where they are. And we can see that we're not getting a lot of cancellation yet at 20 hertz. It's hard to cancel 20 hertz without large distances. Here we are seeing this tilt a little forward, where we're getting more energy in front and a little less behind at 40. And here it's improving even further. We have more energy in front than behind, and if the stage was here. And we've got our nulls, not unlike we had with one sub per side. Now we're really starting to see it. So this has got an excellent amount of cancellation on stage and nice even coverage out front. We've got our two big nulls, and I'll show you how to address those as well in future videos. Look at all that cancellation here, and look at all of the coverage throughout the area. And let's go up to 100. We've got some blowback at 100. Now remember that the crossovers are rolling this off, so we will see a reduction in this. So we're looking at the frequency response. We have good frequency response. I attribute the smoothness of high frequencies out here. I put a higher weighting on that of importance. And blowback at the higher frequencies where we have level reduced is tending not to be as much of an issue. Here, this is indicating that we're at 125 hertz, which is an octave above our 63 cutoff. But we're also seeing a null in the sound position or the central mix area. So this would be a concern. So I would say that this array is pointed too far outward, and I would actually rotate this about 15 degrees in order to fill that in a bit. And that would also take these rear nodes that are blowing back onto stage and move them out here a little bit and get us a little less energy in the middle of the stage. So that would be beneficial. And we're able to see that by looking at the higher frequencies. And here we can really see we're at 160, an octave above an 80 hertz low pass that most subs would see. But also it's saying that it's not going to be a punchy, it doesn't have the response up here. Again, this is a good indication that we're pointed too far out, and we really can see where our energy centers are. And 200 and 250. I'm going to go back down. We can look at this at lower frequencies. So looking at this at 80, 63, and 50, we might not notice that this is pointed too far out. It looks pretty even throughout the area. This is actually quite a good setup, and we would just want to angle that inward more. All right. Two dual 18s pointed forward and one at 90 degrees, no delay, plus one spaced and delayed end fire. This is a setup I really like and comes in handy, and I think that for anybody setting up small to mid-sized systems, this is a setup to consider. Because you can take that 4 subs per side array, and rather than just putting all 4 subs, rotate one 90 degrees and take the other one and space it out. And within a few minutes, you can convert the 4 subs per side into this setup. Or if you don't like it, convert it back again. with a very, very small amount of effort and utilizing almost the same amount of real estate out here and not really changing the dynamics of the show or moving barricades and stuff like that in most situations. You will need one processor out to drive these three and a separate processor out to drive this, because these will all be at 0 milliseconds and this will be at plus X milliseconds, and X would be the distance from the front of the speaker to the front of that speaker approximately. And what this does, it gives us a new level of control. If we put this outside sub at 0 milliseconds, then it's almost exactly like having all 4 subs pointed forward with the energy center of these subs moved back a couple feet. So the energy center here, 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 here. So it's kind of like just slightly tilting us outward if they're all at 0 milliseconds. As you move this later in time, then the energy coming out of this sub as it spreads then hits this one. You're increasing the amount of energy being radiated 90 degrees off axis. So what you're able to do is take and by increasing the time on that outer sub, increase the width of your coverage with a very simple setup. So let's go ahead and look at that at 20 hertz. Now, back in the other images where I showed all 4 subs pointing forward, you can look back in the video. These are deeper notches. You'll see that we have a little less cancellation here. These nodes are not as dark. And here we've got good coverage off to the side. We've got some nodes. We've got good coverage at mixed position. It's fairly smooth throughout. Let's see how fast this moves. I'll set the mouse there. And we can see that it's moving in pretty quick. We're seeing that what we want to see is that as you go up in frequency, you want these flowers to move fairly quickly. We don't want them to sit there and just barely move and leave these notches where they are. All right, so let's go to the next one. And the notches have gotten deep. There's that darker notch. But look how much coverage we're getting out here. So we've got 40% of our audience, 40% of our audience, and 20% of our audience. And I'll go up higher. And it still looks really good. Let's go ahead and I'm going to go back and call out these frequencies because they're not written there. That looks like 20 hertz. And I'll go back and, 20 hertz, 40, 50, 63, 80, 100, 125, 160, 200, 250. So here we're starting to see the ramifications of this delay that's been put on here. We see this node. If we reduce that delay time, this will fill in and this will drop down. So this energy will move in this direction. And so we're able to, and it'll look more like that. So this holds up to about there. So let's go back down to 20, 40, 50, 63, 80. It holds up well to 80. And then we start to see it at 100 hertz start to pull out and start to fire out here. But it still hasn't really hurt the integrity. We're not seeing things jump around in the coverage field in an inconsistent way. So I would say that I would reduce the delay time on that to a lower time period. I don't remember what it was for this, but this is, put 1, 2, 3 milliseconds on that side and then do the predictions or just listen to it. All right, so that's a really simple, cool way to increase coverage and reduce many of the complexities. I'm going to go back one more time. Do you remember on that 4 subs per side, how it just turned into these 2 laser beams that just showed up right there? In fact, I'm going to go back and take a look at that. There we go. There's 4 subs per side at 63 hertz. There's this at 63 hertz. So the beauty of the slight shift is significant. All right, so in part 3, the next video, I'll talk about even more complex setups like the Orgasmatron or Vortex setup I took out on Chili Peppers and Blink-182 tours, as well as the Endfire fans, which I used on Soundgarden and Chili Peppers, and has become one of my favorite setups to use. Cool.